Let's move to the next question. In this question, two dice are thrown at the same time, and we have to find the probability that the sum of the two numbers appearing on the dice is 8. In the second question, we have to find the probability that the sum of the two numbers appearing on the top of the dice is more than 10. So let's work out the problem. Here, when a single die is thrown, either 1, 2, 3, 4, 5 or 6 may appear on the upper face of the die. So totally, when a single die is thrown, we have 6 number of possible outcomes. What happens to the total number of outcomes when two dice are thrown? So when two dice are thrown, 6 outcomes are appear on one die. Similarly, 6 are appear on the other die. So the total outcomes are 6 times 6, which is 6 square, and it is equal to 36. The 36 possible number of outcomes are tabulated here, and here the first number appearing on each ordered pair is the first number on the upper face of first die. Similarly, the second number is the second number appearing on the second die. And here we have to find that the sum of the two numbers appearing on these dice is 8. So first we take is the event which denote that the sum of two numbers appearing on the die is 8. When we get the sum 8, so we don't know the number of outcomes, we assume 1 is on the first die, and then we think of a number in between 1 and 6, including 1 and 6, whose sum with 1 is 8. There is no such a number. Then we move for next number, which is 2. Is there a number in between 1 and 6, including 1 and 6, whose sum with 2 is 8? Yes, there is a number 6, such that 2 plus 6 is equal to 8. So we have one outcome, which is 2, 6. Since 2, 6 is one of the outcome, 6, 2 is also another outcome. Then we move for next number, which is 3. And here we question ourselves, is there a number whose sum with 3 is 8? Then we have a number 5, and the sum of 3 and 5 is 8. Then our outcome 3, 5 and 5, 3 are our required outcome. Then we move for next number 4, and there is a number 4 whose sum with 4 is 8. So here we have 4, 4 is our outcome. So totally the sum of two numbers is 8 when we appear 2, 6 as one outcome, and 6, 2 as another outcome, 3, 5 as one of the outcome, and 5, 3 is another outcome, and 4, 4. So the total number of possible outcomes to the event E is 5. So the required probability that the sum of two numbers is 8 is the number of outcomes favorable to event E, which is 5, to the total number of outcomes, which is 36. And then we have to find out the sum of two numbers appearing on the dice is more than 10. To get the sum more than 10, the sum must be 11 and 12. So here we denote F is the event that the sum is more than 10. So when we get the sum more than 10, to get the sum 11, the number on each die either 5 or 6, that is 5, 6 should be one outcome, and 6, 5 should another outcome. So the favorable outcomes to get the sum 11 is 5, 6 and 6, 5. Similarly, to get the sum 12, the number on each die should be 6, 6. So 6, 6 is the another favorable outcome to event F. Then the probability of event F is P of S, which is the ratio of number of favorable outcomes to event F, which is 3 to the total number of outcomes, which is 36. Here the numerator and denominator contains the same factor 3. So 3 goes in 36 12 times. So the required probability is 1/12. And this completes our solution. Let's move to the next question. In this question, we are given a right angle triangle whose sides are 15 cm and 20 cm, and the right angle triangle is revolved about its hypotenuse. Then we form a double cone. We have to find out the volume and surface area of the double cone. Let's work out the problem. Here we take ABC, a right angle triangle, and if we revolve the right angle triangle ABC about its hypotenuse AC, then we form a double cone like this. Here the upper cone is the first cone, and here we have lower cone, and it is the second cone. According to the problem, we have to find out the volume and surface area of this cone. So how we can find it? To find this, we have given sides of triangle ABC. So we take AB is 15 centimeters and the other side is BC and it is 20 centimeters. And here by using Pythagoras theorem, we can find out the hypotenuse of triangle ABC. According to Pythagoras theorem, square of hypotenuse is equal to sum of the square of other two sides. Here BC and AB are two sides and AC is hypotenuse, so AC square is equal to AB square plus BC square. Let's substitute the values. We have AC square is equal to AB is 15 centimeters, so 15 centimeters whole square, and BC is 20 centimeters, so 20 centimeters whole square. We get 15 square is 225 and 20 square is 400, and the sum is equal to 625. Then we have AC square is 625. By applying square roots, we get the value of hypotenuse, which is 25. Since 625 is a perfect square, square root of 625 is 25 centimeters. And then we get the three sides of triangle ABC. Here, when we revolve the right angle triangle about its hypotenuse, we get a circle, that is the base circle. And here we have to get the radius of this circle, and it is equal to perpendicular drop from vertex B to the hypotenuse. Let it be BO. Then here we have BO. Therefore, the radius of base circle of two cones is BO. And here O is the center of the base circle. So to find the volume and surface area, we have to find out the radius of base circle, that is BO. So here we have the important step to find BO. Here we have a right angle triangle and all its sides are known, and we draw a perpendicular from vertex B to hypotenuse AC, and it intersects at O. Here we redraw the diagram with base AC. Then we have a triangle ABC like this, and this becomes our hypotenuse AC. From vertex B we are dropping a perpendicular like this, and here we know the all sides. In both these triangle, area of triangle ABC is equal to area of triangle ABC. We know that area of a triangle is half base into height. Here base is BC, so BC, and height is AB. Similarly, in the second triangle, that is ABC, base is AC and height is, here we have BO, perpendicular, that is BO. So by using this we find out the value of BO. Let's substitute the values. On both sides half get cancelled, and BC is 20 centimeters and AB is 15 centimeters, and here we have AC which is 25 centimeters, and we have to find out BO. By rearranging and transposing 25 to left hand side, we get 20 times 15 upon 25. By simplifying, we get the value of BO, which is 12 centimeters. So by using this, we can find out the volume and surface area of the double cone. So now we get the value of BO, which is 12 centimeters. Let's redraw the double cone here, and here we have its figure. So here the volume of double cone, here the volume of double cone is equal to sum of the volume of first cone and second cone. Volume of a cone is 1/3 pi r square h. Radius of base circle is same, so pi r square. h1 is the height of first cone. Similarly, h2 is the height of second cone. By taking 1/3 pi r square common, we have h1 plus h2. Let's substitute the values. Here we are given the value of pi, which is 3.14, and radius is equal to BO, and it is 12 centimeters. Height of first cone is unknown and height of second cone is unknown, but sum of their heights is equal to hypotenuse, and here we have hypotenuse 25 centimeters. So h1 plus h2 is 25 centimeters. By simplifying this, we get the volume. By simplifying this, we get the volume of a double cone is 3768 centimeter cube. Similarly, we have to find the surface area. Here the surface area of a double cone is the sum of the curved surface area of cone 1 and curved surface area of cone 2. And it is equal to pi RH, where r is the radius of base circle and h is the height of cone. In the first cone, we have h1 is the height of cone, and similarly in the second cone we have h2 is the height of second cone. By taking pi r common, we have pi r times h1 plus h2. Let's substitute the values. Pi is 3.14 and radius is 12 centimeters. Sum of heights is the hypotenuse, which is 25 centimeters, and it is equal to 1318.8 centimeters square. And this is the curved surface area of the double cone. This completes our solution. In this question, a spherical shell of lead whose external diameter and internal diameters are 24 centimeters and 18 centimeters, and it is melted and then recasted to form a right circular cylinder of height 37 centimeters. And here we have to find the radius of base of the cylinder. So let's work out the problem. Here we have a spherical shell of external radius capital R and internal radius small r, and we are given external diameter, which is 2 times capital R, and it is equal to 24 centimeters. We get the radius of external shell, which is 12 centimeters. Similarly, diameter of internal shell is 18 centimeters. We get the radius of internal shell, which is 9 centimeters. Here we are given the spherical shell is melted and recasted to form a cylinder. Here we have a cylinder and its height is 37 centimeters. So we have to find the radius of this base circle. So we assume it is R1. So how we get its value? To get this value, one form of solid is converted into another solid. So in both process, volume of spherical shell is equal to volume of right circular cylinder. So by equating these two volumes, we get the value of R1. So let's frame an equation. To get the volume of this shell, we have to subtract the volume of inner shell from the volume of external shell. Volume of external shell is 4/3 pi capital R cube, and volume of inner shell is 4/3 pi small r cube. And volume of cylinder is area of base circle into its height, which is pi r1 square times h. By taking 4/3 pi common, we remain with r cube and small r cube, and here we have pi r1 square times h. Let's substitute their values. Here we have height of cylinder is 37. So on left hand side and right hand side, pi get cancelled, and it is equal to 4/3 pi. 12 cube is 1728 and 9 cube is 729. And we don't know R1. So we get the equation like this. Here R1 square is equal to 4 times 333 upon 37. By applying square roots on both sides, we get R1 is equal to 13.79 centimeters. And it is the radius of base circle. And this completes our solution. Let's move to the next question. In this question, we are given sum of the areas of two squares is 400 centimeters square, and the difference between their perimeters is 16 centimeters, and we have to find out the sides of two squares. Here we take A and B be the sides of two squares, and we know that area of a square whose side is S square. So we are given the sum of areas of two squares, which is A square plus B square. It is equal to 400 centimeters square, and we are given another condition. The difference between their perimeters is 16 centimeters. So 4 times b minus 4 times a is 16 centimeters. Taking 4 common, we get b minus a is equal to 16, and by dividing with 4 we get b minus a is 4. This implies the value of b is a plus 4. Let's substitute this value of b in this equation and we get the value of a. Then we have a square plus b square is 400. So on substituting the value of b, which is a plus 4, we get a square plus a plus 4 is equal to 400 centimeters square. Now a plus b whole square is a square plus 2ab, that is 8 times a, plus 4 square, which is 16, and it is equal to 400. Now a square plus a square is 2a square plus 8a, and when we bring 400 to left hand side, we get negative 400. 16 minus 400 is minus 384, and it is equal to 0. By dividing with 2, we get a square plus 4a and minus 192, and it is equal to 0. So let's observe the factors of negative 192, and it is equal to negative 16 times 12 or negative 12 times 16. Since we have the coefficient plus 4a, so we take these factors, negative 12 times 16. So we have a square plus 16 times a, negative 12 times a, minus 192. By taking a common, we get a times a plus 16, and by taking negative 12 common, we get a plus 16. From these two terms, we take a plus 16 common, we get a plus 16, and we remain with a minus 12. So to get this equation to 0, each factor must be 0, that is a plus 16 is equal to 0 or a minus 12 is equal to 0. Then we get the value of a, that is negative 16, or a is equal to 12. Since we have taken a is the length of side, it should be not in negative, so we eliminate the negative value and we take the positive value, which is 12. So the length of one square is 12 centimeters. And we know the relation with another side, which is b, and it is equal to a plus 4. So b is equal to 12 plus 4, which is 16. So the sides of two squares is 12 centimeters and 16 centimeters, and this completes our solution. So let's move to the next question. In this question, we have a 2-digit number, and it is such that the product of two digits is 35. When 18 is added to this number, the digits interchange their places, and we have to find that number. Let's work out the problem. According to the problem, here we have a 2-digit number, so the product of the digits is equal to 35. When 18 is added to 2-digit number, we get their places interchange. That means the tens digit becomes the units place and the units place becomes the tens place. So here we have to determine this number. So let's solve it. Let xy be a 2-digit number. Given the product of the digits xy is 35. So xy is equal to 35. And when 18 is added to this 2-digit number, we get the digits interchange their places. That means the number formed is yx. So we cannot add 8 to y and 1 to x. So we determine the number. Suppose we have a number which is 24. We can write 24 as 4 times 1 since it is in ones digit. Similarly, 2 is in tens digit, so 2 times 10. So we can write this number as 2 times 10 plus 4. Similarly, we can write xy. Here the units digit is y and tens place is x. Then the number we have 10 times x plus y times 1, which is 10x plus y. Now we add 18 to this number. When we add 18 to this number, the digits are interchanged. Then we get the number yx, and we can write yx 10 times y plus x, since y is in tens place and x is in units place. So it is equal to 10 times y plus x. Now we simplify this equation for any of this value, and we have two conditions, which is the product of two digits is xy, and we get this equation. So from this equation we get the value of xy. Now we transpose the terms on right hand side to left hand side. Then we have 10x minus x, that is 9x. Similarly, y minus 10y is minus 9y plus 18 is equal to 0. So then we have 9 is a common factor. So by taking 9 common, we get x minus y plus 2 is equal to 0. We already have the product of x and y is 35. To eliminate any variable, we multiply either this equation with x or y. So by multiplying with x, we get x times x minus y plus 2 is equal to 0. Then we get x square minus xy plus 2x, it is equal to 0. That implies x square, and we have value of xy, which is 35 plus 2x is equal to 0. Here we have the constant term negative 35. Its factors are negative 7 times 5 or negative 5 times 7. So when we add the factors, negative 7 plus 5, we get negative 2, which is not equal to coefficients of x. So we take the factors negative 5 and 7. Then we have x square negative 5x plus 7x negative 35 is equal to 0. By taking x common, we get x times x minus 5. By taking 7 common from these two terms, we get x minus y. Here we take x minus y common, x minus 5 times x plus 7, which is equal to 0. So the value of x is x plus y is equal to 0 or x plus 7, So we have the equation x minus 5 times x plus 7 is equal to 0. Here x should be 5 or x should be negative 7. Since the digits are in not negative sign, so we take the positive value, which is x is equal to 5. Then we get the value of y, which is 35 upon x, and it is equal to 7. Therefore, a two-digit number is xy, and it is equal to 57. Let's check our answer. When we add 18 to this number, we get 75. Here the digits are interchanged. So our answer is right, and 57 is the required two-digit number. And this completes our solution. Let's move to the next question. In this question, each year a tree grows 5 centimeters less than it did the preceding year. If it grew by 1 meter in the first year, in how many years it will cease growing? That means we have to find out the number of years in which the tree stops its growing. And we are given condition is, if we take x units is the height of the tree in a year, and in the next year it grows by x minus 5 units. So this is the meaning of this question, and we are given the tree had grown 1 meter in the first year. That means in the first year its height is 100 centimeters. According to this sentence, each year a tree grows 5 centimeters less than it did in the preceding year. So here we have 100 centimeters. In the second year it grows by 95 centimeters. In the third year it grows by 90 centimeters. So on, it will take to 0. That means it stops its growing. So here we have sequence of growth which is in AP. Clearly the first term is 100 centimeters, and we know that common difference is the difference between a term and its preceding term. We take the term 95, its preceding term is 100 centimeters, so value is negative 5. We know the nth term, but we don't know the value of n. Here we have to find the value of this n, and it is equal to 0. We know that a is the first term and d is the common difference. Then the nth term is a plus n minus 1 times d, and it is equal to 0. Let's substitute the values. A is 100 centimeters and N is unknown to us, and we know the value of D, which is -5. 100 is equal to, let us transpose this -5 times n minus 1, and it becomes 5 times n minus 1. On dividing with 5 on both sides, we get 20 is equal to n minus 1. That implies the value of n is 21. Therefore, tree will stop growing in the 21st year. And this completes our solution. Let's move to the next question. In this question, the angle of elevation of a jet aircraft from a point P, which is on the ground, is 60 degrees. After a flight of 15 seconds, the angle of elevation becomes half of the previous angle. That means it is 60 degrees divided by 2, which is 30 degrees. If the jet is flying at constant speed, which is 720 kilometers per hour, and we have to find the constant height at which the jet is flying. To solve these kinds of problems, first we draw a simple figure to get the whole description of the above question. Here we take P be a point which is on the ground, somewhere at a height about unknown, A be the position of the jet. For the first time, the angle of elevation of the jet from a point P is 60 degrees. So this angle becomes 60 degrees. Now, after a flight of 15 seconds, the jet either moves towards the point or away from the point P. So we don't know this, so we proceed for further information. Here the angle of elevation becomes half of the previous angle. That means the angle is reduces, so the distance of the point from the jet increases. So it moves away from the point, and here is the position of jet after 15 seconds. Let it be C, and at this position the angle of elevation is half of the previous angles, which is 30 degrees. And we are interested to find the constant height at which the jet is flying. And this is the constant height, and this is also the same constant height. Let it drop a perpendicular from A and C, which touches the ground at B and D. We have to find AB or CD. Both are equal since it is flying horizontally, and we are given angles. So using this, we have to find AB. Now we assume h meters be the constant height at which the jet is flying. Now we assume h meters be the constant height at which the jet is flying, and we are given the speed of the jet is 720 kilometers per hour, and we are also given that it has taken 15 seconds. So time taken by the jet to move to point C is 15 seconds. From the definition of speed, speed is the distance traveled by the body per unit time. So we are given time in seconds. We find the distance, which is AC. It is 720 kilometers per hour, and we have the time, which is 15 seconds. And it is equal to our distance, which is AC. We know that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. Totally we have the value of 1 hour, which is 3600 seconds. So 1 second is equal to 1 upon 3600. So let's substitute it. 1 hour 3600 seconds, and it is equal to our distance. Now we get the value of AC, which is 720 times 15 divided by 3600, and it is in kilometers, and it is equal to 3 kilometers. We convert it into meters, it is equal to 3000 meters. So the distance traveled by the jet in 15 seconds of time is 3000 meters. Let us assume the distance of the point P from BB x meters. Then in triangle APB, it is a right angle triangle, and we have 60 degrees, and perpendicular is h meters and the base is x meters. So we consider tan tan of 60 degrees is equal to ratio of perpendicular, which is h, and base is x. Tan 60 degrees is root 3. It is equal to h upon x. Therefore, we get the value of h, which is x times root 3. So we have two unknowns, x and h. So we use another triangle, which is CPD. Here we have angle 30 degrees and the perpendicular is h meters, and we know AC, that is the distance traveled by the jet, which is 3000 meters. So here we have tan of 30 degrees, which is the ratio of perpendicular, h upon to its base, which is PD. Here tan of 30 degrees is 1 upon root 3, h is unknown, and PD is sum of x and 3000, which is x plus 3000. We have got the value of h, which is x times root 3. Let's substitute the value of h and eliminate one variable. Here we have x times root 3 and x plus 3000. Let's continue it in the next page. 1 upon root 3 times x times root 3, x plus 3000 we have. By cross multiplication we get x plus 3000, it is equal to x times root 3 is 3. Therefore we get 3x. By transposing this x to right hand side, we get 3x minus x, which is 2x, and it is equal to 3000. Therefore the value of x is 1500 meters, and we have got equation, which is h is x times root 3. What we have assumed, h is the constant height at which the jet is flying. So it is 1500 times root 3, and we are given the value of root 3, which is 1.732. By simplifying this, we get the value of height at which the jet is flying, 2595 meters, and this completes our solution.